Okay, welcome to my next edition of Honors Algebra Help. Today we'll be working on number 35 of page 542, which is actually assigned for homework. So if you watch this video and copy the steps and understanding what I'm doing, then you will have completed one of your homework problems due Wednesday. First thing I wanted to point out with this problem, you could potentially solve this by factoring, and in fact that's the easier method in this case to solve, but the directions here ask us to solve by completing the square, and I will go ahead and do that. The reason I just copied this chart from page 548 in your book. You'll see here factoring can sometimes be used to solve quadratic equations, whereas completing the square can always be used. So we want to get in the habit of completing the square for those problems, which factoring becomes impossible. So we have the original equation x squared plus 4x plus 3 equals 0. From here, we want to get our second degree terms and first degree terms, in this case x squared and 4x, by themselves on the left hand side of the equation, and our constants on the right. So we just simply subtract 3 from both sides, and we're left with x squared plus 4x equals a negative 3. Okay. From here, we want to add a constant to both sides of the equation that will make the left-hand side of the equation a perfect square trinomial. And the rule for this, we look at our coefficient of our first degree term. In this case, the first degree term is 4x. Our coefficient is just a positive 4. We take that positive 4, we divide it by 2, and we square that. So in this case, 4 divided by 2, well that's 2, and if we square 4, we're just left with 4. So we're going to add 4 to both sides of the equation. Whoops. And we'll be left with x squared plus, I rewrote this wrong, 4x plus 4 equals negative 3 plus 4, and I'll just simplify that right away. That's 1. Negative 3 plus 4 is 1. Okay, from here we can factor out x squared plus 4x plus 4. We are left with a perfect square trinomial, and we just worked that out. So we can take the square root of our first term and the square root of our last term, add those together and square it, and we'll get a factor. In this case, the square root of x squared is x. The square root of 4 is 2 or negative 2. We check the coefficient here to see if it's a negative positive sign, to see what sign we use in our factor. It's a positive sign. Squared equals 1. We could, of course, check our work by multiplying this out. We should be left with x squared plus 2x plus 2x plus 4, or x squared plus 4x plus 4. Okay. From here, we can use the square root property, take the square root of both sides. Well, you'll notice this entire factor is squared. When you take the square root of something squared, you're just left with itself. So the square root of x plus 2 squared is just x plus 2. And the square root of 1 is plus or minus 1. We can check that. Negative 1 times negative 1 is 1. And positive 1 times a positive 1 is still 1. So be careful to include that plus or minus sign. From here we simply solve for x, x is equal to -2 plus 1. X is also equal to -2 minus 1. This equation we have x equals -1. This equation we have x equals a -3. From there we can go into our book, check the answers, see if we're right. Number 35, -3 and -2, that is correct. That is how to solve number 35 by completing the square. I hope this was helpful. I will post this document on RedWeb under this heading, page 542, number 35. If you're having trouble, I would recommend looking at the proof for the quadratic formula. That should help with completing the square. There it is.